So today we're going to learn how to solve a quadratic by graphing. So we need to be a little bit more accurate in our graphing. So try to be careful when you're graphing. And the solution, or they call them roots usually when we're doing quadratics, is to find the x-intercepts. They're also called zeros. So you'll hear all sorts of words, roots, zeros, anything like that. That is the solution. And remember what x-intercept means? It's where the graph of whatever we're doing crosses the x-axis. So in this case, where the parabola crosses the x-axis. So what could happen when a parabola crosses the x-axis? Well, how many solutions would we have here? 2, so that's one idea. What else could happen? Well, it could over and downward. We'd still have 2 in that case. What happens if the vertex point is on the x-axis? How many solutions would we have? 1. What happens if it looks something like this or something like this? How many solutions would we have? No solutions. So those are kind of the different situations we can come across. So we want to graph this. You can either use your axis of symmetry. You can just look for ordered pairs. I don't really care how you do it, just so you get it graphed. I think I'm going to go ahead and try to find my axis of symmetry. And my vertex point now tell me where I need to go on either side of it. So I have negative. My b in this case is 6 over 2 times 1. So that actually gives me negative 3. Now I'm going to put in negative 3 up here and find my vertex point. Negative 3 squared would be 9. Plus 6 times negative 3 would be negative 18 minus 7. So this is negative 9 minus 7. So I get actually my vertex point is negative 3, negative 16. So in order to do that, I probably need to go by at least 2s on my graph. Well, 2 work, 2, 4, 6, 8, 10, 12, 14. Yeah, so we'll pretend there's one more line. So we're going to go by 2s on this graph on the x-axis. We'll still use 1s on this. So it's actually going to be right down there is the vertex point. So that kind of helps me. I know that's where it's going to turn. So now I could pick a point on either side. I'm going to again choose 0 as one of my points. So if I put a 0 in, I will get negative 7. So 0, 2, 4, 6, 7. So again, remember I have one that is 1, 2, 3 over. So on this side, 1, 2, 3. Yeah, maybe. Hopefully it's not going to go too far off my graph. If I put a 1 in, let's see what we're going to get. So 1 squared is 1, plus 6 times 1 is 6, so that's 7 minus 7, I get 0. So I need 1, 0 right here. So again, that's 1 more over, so it's going to be right here. So it is going to stay on my graph just barely. So there is my parabola. A very well drawn one. So what are the solutions? We get x equal 1. Because of right here, and then we get x equal 1, 2, 3, 4, 5, 6, negative 7. So those are the actual solutions to this. And could you factor this and get that? Yes, you could. Some of them are factorable, some of them aren't. So remember, factoring is another way to solve, but we're looking at the graphing method to solve these now. So lots of little steps there to get that answer. All right, again in this one, again, we might want to find our axis of symmetry. So x equals negative 4 over 2 times 1. So x equals negative 2. If I put that in, I'm going to get negative 2 squared is 4, plus 4 times negative 2 would be negative 8, minus 4. So that is going to give me... Oops, sorry, I did something wrong to start with. I should have added 4 to both sides. That's the problem. So this should actually be a plus 4. So that gives me actual vertex points of negative 2, 0. So make sure it is set equal to 0 first. Forgot to say that. So I add 4 to each side to get it equal to 0. So you do need to make sure you do that first. Sorry about that. So my vertex point is negative 2, 0 right here. If I put a 0 in, I am going to get, whoops, not there. 0 in, I'm going to get 4. So 0, 1, 2, 3, 4. And again, I know I'm going to have another point, 2 over here and right up here. And since that is the minimum point, I know my solution is x equal negative 2, and it has one solution. Oops, guess I'm using b, aren't I? b equals, sorry about that. All right, let's look at another one. So this one is set equal to 0. Don't forget to check that first. I forgot that on the last one. And so if we want to get our vertex point, we're going to have x equal, or first our axis of symmetry, we're having a hard time today, negative 1 over 1 times 1, so that's going to be x equals 1. So that's my axis of symmetry. If I put a 1 in, oops, again, I'm making mistakes everywhere. Get a 2 there, 2 times 1 is 2, so my axis of symmetry is x equal negative 1/2. Sorry, positive 1/2. So positive 1/2, finally I got it. So let's look for my vertex point. And I have to work with fractions here. 1/2 squared would be 1/2 times 1/2, which is 1/4, minus 1/2 plus 4. Well, 1/2 is 2/4, remember? So 1/4 minus 2/4 would give me negative 1/4, plus 4 would give me 3 3/4. So my vertex point is 1/2, 3 3/4. So over half, 1, 2, 3. So again, you got to approximate. Oops, hard with this marker here. So something close to that would be the vertex point. If I put a 0 in, what am I? Oh, again, I keep putting it in the wrong place. If I put a 0 in, what am I going to get? 4. So 0, 4 is going to be right there, right above that. And so I know there's going to be one on 1 like that. So it's really going to look like that, a little parabola like that. So the point is, what is the solution? No solution. So a lot of little mistakes I made in there, so you need to be careful and not make those mistakes like I did. All right, let's look at another one. This time it says if integral roots, remember that means integers is what they would be, so cannot be found, you're going to estimate the roots by stating the consecutive integers between which the roots lie. I should have a graph here. So we'll have to sketch a graph real fast, I guess. All right, so you start the process the same way. You never really don't know this is going to happen until you get to the graph. So I'm going to start by finding my axis of symmetry. So I get x equals negative 6 over 2 times 1. So I get x equals negative 3. I'm going to put that in. Negative 3 squared would be 9. Plus 6 times negative 3 would be negative 18. Plus 7, so this would be negative 9 plus 7, so I'd get negative 2. So my vertex point is negative 3, negative 2. So hopefully I can be accurate enough here. So negative 3, negative 2 is right here. I do know it opens upward, right? So I'm going to try some other ordered pairs. If I stick in a 0, I'm not sure where to make my table here so we can have room. I can do that right. Put in a 0, I'm going to get 7. So I need to even extend my graph farther. 0, 7, 1, 2, 3, 4, 5, 6, 7 is going to be about right there. And on the other side, it's going to be about right there. Okay, let's put in something between there. Let's put in a negative 1, get a little closer to home so I can tell where I'm going. So if I put in a negative 1 squared is 1, plus 6 times negative 1 is negative 6. That gives me negative 5, plus 7 would give me 2. So negative 1 is 2. So now again, I know I have a point over here. So this should be over a little more, I think. Because that was 2 over, so 2 over. So I don't know if we're going to get the right answer here or not. It's kind of hard when I don't have very accurate graphs. Again, I didn't make a very good curve. It really is supposed to be a curve. So we see it doesn't go between whole numbers. Let's see if it goes between the right thing that I was supposed to get. This one is correct, so it's between. So you would write your answer as between negative 1 and negative 2. I guess I don't need a comma there. And then 1, 2, 3, 4. This one was supposed to come over a little more like this. So it's supposed to be between, well, I guess I can say that, negative 5 and negative 4. So be accurate. So it'd be nice to have graph paper.